Okay, so you've got this bench with two objects on it. It's P and P and Q sitting on the bench, and they you assume they're the same starting temperature, and they are losing temperature at a certain rate. So P is losing temperature. That's what they've written is that temperature of P is 18 plus 75 e to the minus 0.09 t, and Q is a different formula, so it's 18 plus 60 times e to the minus 0.01 t. Okay, so let's figure out the answers. The first part says find when the two objects have the same temperature. That's easy, that's just when they're equal, so 18 plus 75 e to the minus 0.09 t equals 18 plus 60 e to the minus 0.01 t. We could cancel out the 18s if you wanted to and do the calculation, but you don't even have to do that. Plug it into your calculator and you get the answer about 2.79 hours, minutes. Okay, second part of the question, find when the two objects are losing heat at the same rate. Okay, so when's the rate of change? So rate is a derivative. So for P, the rate of change is the derivative of this first function here. Okay, so that is minus 0.09 times 75 e to the minus 0.09 t. And for Q, the rate of change is the same sort of thing, minus 0.01 times 60 e to the minus 0.01 t. Okay, so they're losing heat at the same rate when this equals this, so we make them equal and plug that into your calculator and find the answer, and you get an answer of t equals about 30 minutes, 30.25. Okay, so the third part of the question says find the time taken for the temperature of each object to reach 25 degrees Celsius. Okay, so what we want, pretty straightforward, is for P, what we want is 25 equals that function, 18 plus 75 e to the minus 0.09 t, and you'll end up getting t equals 26.4 minutes. And Q, 25 equals 18 plus 60 e to the minus 0.01 t, and you end up with t equals, t equals 214.8 minutes. Okay, that seems quite a lot larger. Okay, but that is okay, because, this one here, the first one is decaying at 0.09, and this one's only 0.01, so that's losing heat very, very slowly, so these answers are probably right. In fact, the next question then becomes really easy. Which object's losing heat at a faster rate? Well, obviously Q is, P is faster, because Q takes much longer. Okay, because P is losing heat faster. And you have to justify your answer. Well, it's because P's rate of loss is 0.09, which is not that great, but Q is only 0.01, so it's much slower. So I reckon that's the way to justify your answer. Okay, and then the last part is find the temperature for each body at large values of T. So when T gets very, very big, this should be pretty obvious that as T gets very, very big, what's going to happen to e to the minus a very, very big number is that this is going to end up going to 0, and so the whole the value is going to become okay, let me do an example. So e to the minus 0.09 times a very, very, very big value, like 1 million, is going to be the same as, so e to the very big large number. Okay, so it's a very, very big large number, which is going to tend towards 0. Okay, so whenever t is large, this whole e thing is going to tend towards 0, which means that temperature is going to tend towards 18 plus 0, which is 18. And in fact, that's going to be true for both of them. So for both of them, for large T, the temperature approaches 18 degrees Celsius.